for the Z image turbo model, and whether you're using a AMD GPU like I am, mine is an older one, it's AMD Instinct MI60, or whether you have you just running on the CPU, or whether you even have a NVIDIA one, it doesn't matter. Even if it's new or old, I'm going to show you how you can speed up the generation of images. Okay, so on to the show. Now, before we begin, I'd like to implore you to subscribe, like, follow, and leave comment, because the more people subscribe, the more the algorithm sends it out to more viewers, and those viewers can then join this growing community, share the tips and tricks, or they can request something and I can go research it, and then I'll be able to share with all of you. I share everything. There's no secrets here. So on to the intro. And you see, intro should say Instant Previews TAESD or TAESD setup. So that's the key, but it's going to be a little twist, and I'm going to show you how to use it to speed up. I'm talking very, very, very fast, and you see, seeing is believing. So if you remember, 2 days ago I promised to do a night stream, and unfortunately yesterday I was way too tired. There was some emergency work, and I finished, I think, like 9 o'clock. I had my dinner, and then I was way too tired, and I didn't want to be too lethargic. And then today I had to go clear snow, so I'm still a little bit under the weather, because now I came from Toronto. I went to spend obviously the holidays with the family, and then I came back. So I'm saying the snow has been crazy here. It's been snowing every other day since October the 15th. So I've only had, I think it was like 6-7 days where it didn't snow in November. Anyways, enough of the snow. On to the show. So this was the article which I did a live stream. I made just a few little changes with this article. So what I did is I put the proper license. The license for ComfyUI is the GNU public license version 3, so that's perfectly fine. By the way, I'd like to thank everybody who watched my BSD license video. It did actually very well. I was actually very surprised because I was away. It wasn't a live stream. Thanks for that. So essentially, the GNU public license, it allows you to modify and share the software, but you must make the source code for your changes publicly available somewhere. And of course, you're allowed to use it for commercial purposes, but if you distribute a modified version, it must also be under the GLP, whatever version it was. For example, in this one is version 3, to have to be version 3.0. Now, some people don't like that license. That's why they prefer other licenses. For example, like the BSD licenses, MIT, and there's also public domain licenses. I've reviewed all of them. So, for example, this model, the Z Image Turbo, it's licensed under the Apache 2 license. So that's one license that people do like. That one, obviously, it's highly permissive for commercial applications. It allows you to reduce the model weights and derivative works, meaning that you don't have to share what you have, your derivative works. And for patent rights, it includes an express grant of patent rights from contributors. So now, that's one of the reasons I also like this model. However, despite all that, while the Apache license is permissive, users are generally bound by ethical safety standards. Here are some general safety standards. For example, illegal content. Do not generate or distribute illegal material, right? So for example, of course, you might want to maybe generate something that's not safe for work. For me personally, that's over my head. To me, it's a waste of time, but if some people want to do that, go ahead. You're allowed to do that. So harmful usage, do not use the model for harassment, misinformation, or creating malware. So of course, if you do something like that, the law is going to come down on you, especially if you live in the West. And privacy and rights, do not violate individual privacy or impersonate others without consent, right? Something, just general stuff. Because some people will think, oh, I can do whatever I want. Yes, and you still have to follow the law, right? So even if it's not expressly written in the license, obviously use your common sense. Okay. So I'm just going to do a very quick overview of what we did, where we left off. So as I said before, because I installed ComfyUI two ways. I installed ComfyUI on my host system, which is Fedora 42. It comes with ROCm 6.4. So that one officially AMD dropped support for my GPU, but Fedora does with the continuing support. All AMD did was just remove the tensor files. You can just add them out. It worked perfectly. Now, because I had another version of ComfyUI, I didn't want to download the same models twice, and put all the weights and everything twice. So what I did was I found out that ComfyUI has this, it's called extra models path, YAML file. So when you edit that file, I showed this earlier to you guys. So when you edit that file, what you can do then is you can put the path to your models, and it will pick up from the previous or the existing ComfyUI. So that's a fantastic way. You can reuse it. So why did I do this? That's because I installed ComfyUI Fedora 42 in a distro box. So I was able to run and compare. Now, the one in distro box, the 6.3, that's the one that's officially supported by AMD, or the last version that was fully supported by AMD. It is faster, but also the reason it might also be faster is because I also, for that one, I use the Python wheels for in the virtual environment. But on my particular system, I use the Fedora repository. The reason I did that was because I know that Fedora compiles it for my particular GPU, so I didn't want to install a whole bunch of packages as well. Because right now, I'm sure you guys know, basically the end of 2025 is that memory prices and disk storage prices have gone through the roof since I actually put together this workstation. So I can't simply just be downloading a whole bunch of models and all this stuff. So I have to be careful with the space and memory as well. And I really don't want to buy more memory because this is DDR4. I'd rather buy DDR5 because that will be more future proof for when this particular workstation gets updated. So as you can see, so my particular GPU, it's the AMD Instinct MI60, it has 32 gigs of HBM2 memory. So this is what it actually is able to support. FP64, that means floating point 64, there's floating point 32, floating point 16. Now, the GPU does not support this one, BF16. It also doesn't support FP8. But it does support integer 8, and then obviously I can do, for example, the fastest one will be for me to use this one Q8, okay, with a catch, and I'll explain that later. And so, for example, if I get a model that's Q6, quantized to Q6, Q4, those will be very fast, especially Q4. It will be so fast that even though it's not officially supported in the GPU, it's so fast that it doesn't matter. Now, one of the problems with all the models which are Q8, they're not fully Q8, meaning that they're not fully integers. So they still have maybe some FP16, which is fine, but some of them might have even like some integers FP8, so then it could probably eventually be slower than me just using FP16. So that's one of the issues we have. So now, as I said here, sometimes integer 8 can actually be slower for my GPU because what happens is it will try to convert this into FP16 or BF16. So in that case, something that's actually not even supported in my GPU, like a BF16, will actually be faster. So that's what I'm saying, is be sure you understand your GPU. I'll go over this as well with a specific chat. I'm also a little bit thirsty, I think, because when I was driving to Toronto and coming back, it's a long trip. The heater was on, so I think it really dried me up because I've been drinking a lot of water. Usually when I drink water, I run to the washroom, but for some reason, I've not been doing that. So that means obviously I'm very thirsty. And also, so as I said, this was the setup. Fedora 42 has ROCm 63, which is still officially supported, and for the GPU. And Fedora 43 comes with ROCm 64. It's no longer supported, but I said the workarounds just put the tensor files in there. In 7.1 or 7, I don't know, one of them, AMD officially removed any mention of the GPU. However, you can compile it back. I said some people have done that, so that's fantastic for me. So here are the instructions for the distro box. We're not going to do distro box today because today we're just going to do an addendum to this one. So you can read all this. There's also a video, and this is how I set up the what do you call it? This is how I set up the distro box and install it and all that set up. So it worked perfectly. So one of the problems I noticed about this model, actually probably all the models, is that they do three things. The first thing they always do is, you see here, they de-age, right? So if you have the initial image, they de-age. I kind of dislike that because, especially for this model, I know it's a distilled model. The thing I dislike about that is because now this person is the current mayor of Toronto, Olivia Chow. You see, so it de-aged her. Well, I don't know if this is a completely different person. The problem is, like, she might have looked like that when she was younger. I'm not making fun of her. I'm just saying that it's clearly at first glance it's not her, right? So that's one thing I dislike. I wish it would stop doing that, like don't de-age the initial image, but we'll resolve that today. I'll show you how to do that. And then this was the GNOME desktop, so that one's fine. This one is astronaut riding a horse. I'll explain why it did not do exactly what I wanted. It did like 50% of what I wanted, and or you can think of it actually did 100%. I'll explain that later. And then this one was the chicken run. It did the code part but didn't put the chickens in there. And here's a man wearing a watch. It did the cloud part but didn't do that. So it followed my instructions for the prompt, but it did not use the initial image, and I'll explain to you why that is. This model is, you have to be very specific. It's like talking to a child. You have to be very specific for it. And as you can see here, if I can zoom in a little bit here. So for example, this one took I think it says 16 seconds or 18 seconds. So that's very, very slow. Now this is also with this more runs, like, so obviously the first time it's going to be slow because it's loading the models, but once the models are in the memory, it should be a little bit faster, but it was still kind of slow. Now I did get it down during the live stream to about, I think I got it to 7.55 seconds, and the one in the distro box was 6.55. So I'm going to improve on both of them. Not just improve on both of them, but also to get the result that I want as well, and very, very fast. So with that said, so this was the previous live stream, and this is the one we're watching now, and this one is live. It's live on YouTube. Oops. So I'm going to YouTube, Rambo, BitChute, and Odyssey at the same time. Okay, so this was the result. So the problem, I'll give you an example. So if you go here, the result for the picture of the mayor of Toronto, you see D8 the mayor of Toronto, it didn't like that. And for the GNOME desktop, what did it do? It reimagined the GNOME desktop. So basically, if you see the pattern here, it's not really using the initial image, is what I'm getting at. The astronaut riding a horse, it actually drew the desert, but it didn't actually without the astronaut riding the horse. And the chicken run one, you see it actually drew snow for the picture, but without the chicken run. I'm sure you guys get the point now. Even for the man wearing a watch, you see it had the cloud, but it did not show the man wearing the watch. And finally, it drew the dust, but it didn't draw the spider web, which I actually was the initial image. So I explained all that. So I'm going to stop about right here. Now, so I said before, you need to know your GPU. So go research your GPU. And now, for example, I'm using this Zettler, which I also did, what do you call it? I did a review on for Zettler. So basically, I'm just going to go through this very quickly. So, what is this one? Not now. Okay, so as I said, for Fedora, I'm lucky. I use Fedora. So you see Fedora here. They have the packages in the distribution. I'm using Fedora 43, and you see my GPU is right here, GFX 906. So, and obviously it was also in Fedora 42 and Fedora 41. It was also there. So fantastic. Now, in Fedora 44, which is upcoming, it will come out in spring. That's rawhide right now. It's ROCm 7.1, I believe it is. And you can see my GPU is still there, so meaning that Fedora is going to still support it then. Obviously, there are going to be some limitations. You can see here, it's going to be limited with this RCCL, but the rest of the stuff, surprisingly, it's going to be there, so I'm pretty happy with that. Okay, so the other thing you need to understand is, I said you need to know your GPU extremely well. So I'm going to explain what that means here. So my GPU clearly doesn't have matrix, doesn't have the matrix capabilities. So for example, you see my GPU is right here, Instinct MI60, and you can see it came out, what is it, 8 years ago? Basically 8 years ago. Actually, no, that's 7 years ago. Wow, 7 years ago. Just over 7 years. 7 years and a month-ish ago. So unfortunately, AMD is no longer supported. Now, the reason they claim is because it was Vega 20. It's not one of the DNA, it doesn't have the DNA nomenclature. So can I scroll this way? Okay, yes, I can. Okay, so the important thing is, if you see, my GPU doesn't have any matrix cores. So it's going to be slower for some of those things, but more importantly, oops, what is going on here? The thing is, there we go. So you can see matrix, it has 0 matrix. See, this is matrix FP4. It doesn't have any matrix. So if you notice, everything that has matrix, my GPU, this one, the MI60, it's not there, right? So floating, so for example, floating point, this floating point 8, is it floating point 8? No, yeah, floating point 8. See, it doesn't have, obviously this is matrix, but matrix or not, it also doesn't have floating point 8. So one thing I noticed is a lot of tutorials say, oh yeah, make sure you get the floating point 8 version. Well, that's going to be actually very, very slow in my system. So that's why I shy away from that. So you can see anything that has matrix, even just a simple floating point 8, it's not supported. And you see, even the structured sparsity is not there. Floating point 16, this is a matrix one, obviously it's not going to have it. So this is the stuff it does have. You see this one, like half precision, FP16, it does have it, and it's actually not too shabby. It's at just below 30 teraflops. So I can use this. And you see anything with the structured sparsity, or like I said matrix, it's not going to have it. For example, this is matrix stuff, FP32, it's not going to be there. So one thing it does have floating point 32, so I'm able to use that. But you see anything with matrix 64, it's not there. But just the normal FP64, the peak double precision, it does have that one. It's a little bit slow at 7.4 teraflops, but that's fine. And as you guys get the point. And the one it does have, the fastest for this one is the peak integer 8 performance. You see it's 59 tops. So that's going to be pretty very fast if I can actually get it. Okay, and obviously it will use, so you see this bfloat 16, the GPU doesn't support it, so I can't run those. So I'm saying is just be sure you understand what your GPU is capable, the limitations of your GPU. So yeah, that's about it. That's about it. Now there's another link I'm going to show you guys. This is going to be the last link. Then we can actually. I'm talking about the GPU. So you see here, this is the specifications here. It will tell us here. You see, it says FP16 at 25 teraflops, and then FP32 at 14.7 teraflops. And FP64 is at 7.4 teraflops, and then of course the integer 8, it's at what is this, 59 tops. So which one is the fastest? Which one should I go for? So obviously I would go for integer, but I'm saying there are very few integer 8 ones. So most likely I have to go for the half peak precision. So this is still going to be pretty good because it will be at least more. Less artifacts, let's say that. So that's the one. So that's something. Just be sure you understand your limitations of your GPU. If you see here, there's no floating point 8. So I can't run, I mean I can, but it's going to convert it into FP16, so it's going to be very, very slow. So the reason why the quantized ones like Q4 whatever, they're going to be pretty fast is because they're so fast anyways and so small that it won't matter when it does that. Now, one thing you will notice is I have actually done tests, and I found that integer 8, if I could actually find an integer 8, is actually the fastest. So this is the fastest, and believe it or not, the next fastest one is actually Q4. After that, it goes to FP16. But FP16 and Q4, they're very, very, very close. It's like if you blink, one of them could have won, but Q4 just barely won. So there we go. So those are the type of stuff you need to get. So now, with that said, let's actually go and do something here. So I'm going to go back to the command line here, and I'm going to I use this cooler control because my GPU doesn't have cooling. It doesn't have a cooling apparatus, so I have to use a fan shroud with a 40mm fan. Okay, so let's do the sudo here. So this is going to be for the fan, and the fan is, yeah, it should be running. It should be an IP address here somewhere. Oh, here it is. So this is, I just called localhost 11987. This application is called Cooler Control. I'll show you what that looks like. Go here and just type 1. Yeah, so that's the one there. This is it here. And so this is the CPU temperatures. They're using the BIOS fan profile, so I don't care about that. So that's obvious. This one is the integrated graphics. Don't care too much about that. This Wi-Fi card doesn't really come with a fan, so I don't care. So this is system fan 2. This is the one that controls this dedicated GPU. So at idle, it's around 43 degrees. It says 45 right now because inside here it's 24 degrees. So I'll grab water. Okay, so now you see I have a virtual environment here. The reason I put it up here is because I was using SD Next in Fedora 42. I should probably just move this into the ComfyUI folder. Yeah, I should probably just do that. But for now, I'm going to leave it there. So we'll go to this tab here and we can go cd ComfyUI. Oh, I'm going to actually then just type source back and ROCm. Then activate. Before I run this, I'm going to do a git pull to see if there's any changes. Wow, there's changes already. Wow, I ran this I think just yesterday, and okay, that's it. So just do a git pull and just type pip install space -r and then requirements.txt, and then so to prove to you, as I said before, if we go, let me zoom out a little bit more. If we go here, for example, you see it says requirement already satisfied. You see it's /user/bin Python 3.14. Yes, I'm using Python 3.14, and you see I'm using the site -packages. So this means that it's using my I'll show you here, but the PyTorch, for example, and what's this one here? Let's see. See torch here. The torch has been satisfied in system-wide packages. So that's it. So that's installed by from the Fedora repository. Same with the Touch SDE, Torch Vision. Did I say Touch? I meant Torch. And Torch Audio. As you can see, those are all from the site-wide packages. I did that because I knew they already installed for ROCm. I didn't need to install any wheels, but I used wheels when I was doing the inside Fedora 42. So with that said, now if you have an AMD GPU again, so make sure you understand your GPU. So instead of simply running python space main.py, this file with ComfyUI, instead of running, where's the main file here? Where's M? Instead of just running this, what you should do is know your GPU pretty well, which I know mine extremely well. So what I'm going to do is instead of just running that, what I do is I have a specific one I'll show you here in a second. Where is it? Okay, there we go. So I want it to be in VRAM mostly, so I'm going to say high VRAM because I have high VRAM. I want to use coarse attention, and I want to disable the smart memory because smart memory tries to put stuff into memory, and that's kind of silly. So there we go. So, and then what I'm going to do is I'm going to show you the monitor because this is important. I'll show you this here to you guys. So you see I have 6 cores and of 12 threads, and my memory, even though I have 32 gigs of RAM, I don't really have 32 gigs of RAM, and I'll explain to you why I don't have 32 gigs of RAM. Remember, I have an integrated graphics, so that reserves 4 gigs, so already drops down to 28. And then I also have something called ZRAM for the swap, and that takes another 4 gigs and it basically compresses it. So basically what I really have for usable RAM is actually 24 gigs, right? I don't have the 32 gigs. So yeah, but I'm saying because of some of the things I'm going to show you, so when I'm using an AI video, it's definitely going to go in the swap. Unfortunately, I said I doubt I'm going to ever get more memory for this one because it's DDR4. Okay, so just wanted to show you guys that. I don't know if I should actually leave this open. It doesn't really matter. Yeah, this doesn't matter. All right, so you see this is ready. It says I can go to 8188 localhost. So I want to show you what happened here. So you can see it detected my entire VRAM. And you see the total RAM. I said I don't get the entire 32. So it says here GFX 906. It's using high VRAM. It's disabling the smart memory management. That's important. And it says CUDA. That's because when all these applications were created the first time, it was basically NVIDIA. It was only the game in town. So their names are still, even though I'm using an AMD, it still refers to it as CUDA. And then, where are we here? Other stuff I can show you. So we've got all the tensor files. Everything is perfectly fine. Python, as I said, is 3.14.1.2. And ComfyUI version at time of this recording 0.60. And the front end version is 1.35.9. And as you can see, yeah, everything is fine. So I installed some custom nodes. Here's another reason. I was using the ComfyUI manager, and what I noticed is, for example, I wanted to install one extension which only had 2 nodes. It was taking very, very long time. Like, how long does it take? Is it 2 JSON files? Why is it taking forever? So I looked on the command line. It was trying to install all these NVIDIA drivers. I'm like, oh. So then I said, you know what? Until maybe it's improved, I'll just install the ones I want. So these are the ones I installed, the custom nodes. I installed the ComfyUI use TAESD. I installed GGUF and the ComfyUI-GGUF. So I'll explain to you why I installed these 3 custom nodes, and I got way better speed than earlier. Okay, so let's go here. You can simply just click it, but I'm gonna open it up in a specific. Oh, I can actually open up here as well. So I'll just type here and I type 8. Yes. So I'm going to put ComfyUI here. Okay, I'm going to zoom out. So I'm going to, I should zoom in. So as you can see, this is why I use the unit loader to download the Quantized Q8. Remember I said that's the fastest one. And then I'm using, this one is also Q8 for the clip loader. It's Quen3 4B instruct 2507 Q8. The type is Lumina 2. And then this one here, this is not used for now for resizing because the images I want are going to be 768 by 768, but for this testing one it's 512 by 512. So this one here of the current mayor of Toronto. Actually, this image I think I got it from Wikipedia. I think it was something like 160 by 120. So I just scaled it up and I cropped it so it's a perfect square. Because I was still I wanted various speed, so I was fooling around with SD 1.5, which is limited to 512 by 512. And then you see the prompt here. Let's go to the prompt. You see the clip text loader. I grabbed the one for Lumina 2 because I said I didn't want any issues. I grabbed the one for Lumina 2, and you see it says smiling, photorealistic, cinematic lighting. isolated pure white. Ooh, this got clipped off. This should actually on a pure white. Yikes! 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 Okay, that's not good. That should actually say pure white background. I don't know what happened there. What in the world? I must have copied and something got clipped off. Oh, that was weird. Yeah, I should say pure white background. So there we go. Now, because I'm using this Z image turbo, it doesn't understand negative prompts, right? So just zero that out. This one was a head scratcher for me. It was like, why is this not working? So yeah. So basically, what you need to do is, if you have a negative prompt, you have to put it in here and explain it. You have to put it inside the one prompt and explain it. Or you can do like 2K samplers and have a negative prompt in there. You can do that as well, but it's just easy to do this. Okay. Then it connects to the model sampling Aura Flow. I left that as 3.0. I think I grabbed this from, I was either the default from the default template, or I think I got it from stable-diffusion.cpp, the C++ version. So this connects to the K-sampler, obviously the model, and the positive goes here, and the negative, the zeroed out goes here, and I'll explain the latent image later. Okay, so I'm sure some of you have seen that sometimes I use a fixed number of seeds. That doesn't really matter for now. The results are pretty good for consistency. So if you see this, the steps 1. So before we had 3 steps, now it's 1 step. The CFG, this value, it's best for turbo models or distilled models to leave it at 1. So I left it at 1. I changed the sampler name to Euler because that has been around a long time. It works extremely well. And the scheduler, this one doesn't really matter, so I just left it as uniform. You can also try simple, that's all up to you. Now this is the key part, right, the denoise. If we leave this at 1, so I'm going to leave this at 1 and you'll see what will happen. If we leave it at 1, nothing's going to change, right? So, and then, the other thing I did was I changed the default decoder, the VAE decoder. So you see I'm using the TAESD decode. So what this will do is this will preview the image much faster. However, you can also use it to decode and save your image instead of just previewing. So it'll be much faster. And so I'll show you where I got this model from as well. And then if I zoom out a little bit here, you see I also changed the VA encoder to TAESD encode, and I use the same model. And then this is Olivia Chow here. So I'm going to run this. It should go really, the first time it'll be a little bit slow. And we'll check the temperatures here. If it goes to above 60, I might turn this on, but I think it will be so fast that I probably don't even need to touch this. The first time I said because it's loading the model, it's going to be a little bit slow, but we'll run a second run and you see how fast it's going to be. So it's still in the clip here, it hasn't gone, oh, it's already on the K sampler. And is it done yet? Are you done yet? No. So yeah, the first time is a little bit slow, so what is going on here? That's a little bit slow. Come on. Wow, that is slow. Okay, I don't think that's an OBS thing. That should be... Wow, that is slow. Might have to change it to... Okay, there we go. It's finally working. Okay, it's done. So let's go and see how long it took. You just go to the command line and you go here, and you can see it took a minute, right? But if I run this again, it's going to be much faster. So we're going to run this again, and you see, I'll show you the picture. So the picture, well, if you want to really see the picture, you see what it did. You can say, oh, that's an ugly output. Don't worry about it. So let's run this again. And you see, much faster, right? Don't worry, we'll fix that. Don't worry about it. So if we go back to the command line, you see the first time it took a minute. You see the second time it took 2.50 seconds. So that's pretty good. I'm happy with that. However, let's fix this. So what I found was, if we go here, let's zoom in here. So we change the scheduler to simple. You can also use beta as well. So let's try simple. Yeah, so it's let's see what it looks like. Yeah, that's a little bit better. A little bit better. And they shouldn't have yeah, so you see it's 2.52 seconds. Yeah, that's fine. So we'll fix that. So what I want to show you, don't worry, we'll fix everything. Don't worry. It looks, you might say, oh, it looks horrible. No, we'll fix everything. Don't worry. So so what you do is, let's go back to here. So if you go to your models and we go to VA approx, you see here I have the TAEFI, I have the decoder, and I have the encoder. I also got this one 2.1 pith. This is for the video, but the video is a WAN 2.1. But you see, you have to get the encoder and you have to get the decoder. So this is where you put them. Okay, so and then obviously you have your diffusion models. This is where you see, this is the Q8. You might be wondering why I have two of them. One of them is for the stable diffusion. You see the stable diffusion one is slightly small. I couldn't get it to work in ComfyUI, and this one I'm actually fooling around with it as well. Is this WAN 2.1 fun in paint. You see it's pretty small relative to my GPU. And what's VAE. This was the default one they tell you to use, AE safe tensors. So what I did is this one is how big? 335 megabytes. So I got this one, the pig one. It's a little bit smaller, so this is faster. And then now, and this is for the video. So those are the three that you need for your. Oh, sorry, no, I lied. You also need some text encoders. So where's the text? TTT for text. Why can I see T's here? Am I crazy? Should be text encoders. Oh yeah, text encoders here. So you can see this is the instruct one. You see it's 4.3 gigs. That's a Q8 version. And this Quen FP16, that's 7.5 gigs. And then this one is, I believe, for the video, 11. So yeah, this is for the video. It's pretty big, 11.4 gigs. Okay, so that's what I'm showing. Now let's take a look at our output. I have been testing this quite a bit in the output. Should I put GGUF? Yeah, so these are the images I think that were just recently generated. So let's take a look at this. Okay, there's that one. There's that one and that one. Now you can say, oh, that's horrible. And you're right, it is. I believe the size, let's see what the size is here, 512 by 512. Okay, so let's go fix that. So go back to ComfyUI. Now we go in here and we fool around with the denoiser. So with the denoiser here, we say let's say 0.8. Okay, we run this. Go here. Still not so good. So, oh, this didn't even change. What is going on here? So 0.8. Okay, 0.8. You see, a little bit better. Okay, let's change it to 0.6. It's still simple. Not so good. Let's change this back to this one. I don't know why it's so bad today. Still, what's going on here? Why is it not doing what I want? Oh, you know what? Let me actually read my notes. Yes, I actually do. I think I wrote my notes up somewhere. Oh, yeah, let's see what I did here. Shift is 3. Euler. Oh, beta. Let's try beta here instead. Okay, let's run that. Man, why is the image so not so good quality? Okay, so let me try 0.4. I'm not giving up. Ah, there we go. There we go. So you see? There we go. So I'll explain why the denoise is important. Okay, so if you use a denoise value greater than 0.7, it's going to ignore you and basically just use the prompt, right? So which is not what I want. So if anywhere between 0.5 and 0.6.5, there's going to be some noticeable. It will be not noticeable. However, if you go 0.25 to 0.4, there's going to be light edits. So for example, in this case, I used the 0.4, so there's a little light edit. So obviously it didn't completely take my prompt, because my prompt is supposed to be a white background. So I'm saying, but if I put a better prompt here, it will do what I want. So you can see this looks more like Olivia Chow. I don't know why she's wearing glasses here. She's not. But the point is, you see, it kept her outfit. So this is the type of stuff that I could properly use. Yeah. So and it kept the flag in the background and all that as well. The hairstyle is the same. So what I'm trying to say is that even though it still de-aged her, so this is what she looked like. It wasn't. I said this is not a very good quality because it was like 160 by 120, and I just blew it up to 512 just to get a perfect square. So that's another reason. That's another way to speed up your AI workflow, is that if you instead of having to scale images or cropping them, if you do that beforehand, it will be much faster. So you can save some, especially if you have low RAM or you don't have enough VRAM as well. So I'm pretty happy with that. I'm very happy with that. Okay, so that's basically what I wanted to show you guys. If you go take a look at the command line here, you see that one took 2.51 seconds. So it does actually use my initial image, as you can see here. So let's go try out some of the others. So what I'm going to do is I'm going to do, what's the next one? The next one was the desktop environment. So let's go open up the desktop environment. I know where that one is. That's in AI. And that one, I'm actually going to click this off, tear this off. I have to put it in another monitor. Come on, why can I tear this off? Oh, now it's not letting me tear it off. Okay, then finally, jeez. Here we go. So what I'm going to do is, this is in the stable-diffusion. Go to build. We're looking for the GNOME desktop environment. Where is GNOME desktop environment? Is it G? Here, GNOME desktop environment. So I just drag it and put it in here, and then a prompt here. Okay, so the prompt is going to be different. I'll read what the prompt is going to be here. It says desktop environment, photorealistic, cinematic lighting, isolated in a pure white background. So because I have the denoise level here, it's you see it's actually not done yet. So let's see what it did. I haven't seen this before. This is my first time doing this. So it's 2 jobs are completed. Let's see what the output looks like. It looks a little pixelated, but okay. So this is what the original one looks like. Looks like it. What did it do? Just made it more pixelated and removed this icon. It looks like. So yeah, I said you can. Oh, I think it also tried to. Oh yeah, tried to change some of those images. So there we go. Now, of course, if I put a 1 here, if I put a 1 and run this. Yeah, so then we get the kind of results that because now it's just relying on the prompt. So if you go to say 0.65, yeah, so it kind of does it. If you go 0.25, there. So as I'm saying, like if you fool around with a denoiser, you can probably get something that you might like. So the schedule doesn't really matter because it's so fast. Obviously, if you put more steps, you know it will take a while. But this tutorial is all about speed and getting some decent quality. Okay, so there we go. Now I have another one. This is going to be for the. I think this is the one. Where, yeah, this is the one where the astronaut is riding a horse. I'll read that to you after I put the astronaut here. Astronauts should be A. Here we go. You can run this. It's not done yet. Oh, so it, yeah. So as you can see, just basically took my image and put it here. Obviously, we want the image to be tweaked a little bit. In case you're wondering what the original one looks like, there's probably very little subtle changes. I don't even think there's any change at all, honestly. I'm sure there is if you look carefully, but let's just put this guy here so we can compare. So let's make this 0.4. Oh, that is good. Wow, that is good. I like that one. So you see this one here, look what it did. It re-emerged it, and oh, that is actually very good. You see it kept the desert, and oh, that came out really good. 0.4. That came out much better. Yeah. Wow, that actually came out much better. The horse actually looks more realistic than this plastic type thing. Oh, that actually came out pretty good. Wow. Let's actually see how long that took to do. That one took 2.49 seconds. So wow. So as you can see, so if you fool around with the denoise level, you can probably get a result you want. Obviously, this is not very good quality because it's still 512 by 512. But let's actually go. Let me see. Is it here? Wow, not bad. Not bad at all. Not bad at all. Not bad at all. Yeah, not bad at all. That's not bad at all. Honestly, that's not bad. So I said, so the denoise will let you, as I said, the lower the value, the more it will obviously use the initial image. And the higher the value, the less it will use, and it will rely more on the prompt. Obviously, you can add extra stuff in here, but I'm saying is for my particular use cases, I'm pretty happy with that. All right, so so I forgot to read the. I did not read the prompt to you. I apologize. The prompt is desert environment, photorealistic, cinematic lighting, isolated in a pure white background. So obviously, if you add more, it will actually obey your prompt. The more obviously, I purposely did only this just to compare to the article which I wrote. Obviously, the more you write in the prompt, you can tell it to use the image, do this to the image. You can put all that stuff in, and it will actually honor your request. I'll show you some of the images I was able to generate. I think last week. Okay, so you see here, this one is a snow environment, photorealistic, cinematic lighting, isolated in a pure white background. So this one is the chicken run. Yeah, this is the chicken run here. So put it here. I'm gonna put the chicken run in here and run that. I don't see. Well, the chicken. Wow, the chickens actually look pretty good too. Except I don't see any snow here. Chickens look way better than, yeah. So remember I told you one of the things I dislike is it kind of it kind of like de-ages or make them better. This actually looks really, really good as well, but there's no snow. So remember my prompt was for snow environment. There's no snow environment here. So what you need to do is fool around with this. So it looks like I need to go a little bit higher. So let's say 0.45. Let's see what that will come up with. I want to see some snow. I don't think I see any snow here. Is there some snow? That looks like yeah, that doesn't look too snowy. So let's increase this just to be careful here. Then 0.55. Let's try that one. Oh, then it changed everything too much. It just made it snow. So that's too much. And let me try 0.5. Yeah, see, this is the thing I also dislike about it is that, yeah. So as you can see, yeah, it's this looks more like ducks now. Yeah, so that's one of the problems with the mod. I was like pulling my hair out when I was trying to run this. So you have to be very specific here to tell it to use this one and don't change this. You have to give the color. It's sometimes it's a pain, but once you get the prompt properly, it will work extremely well. So for example, if I put more steps here, let me give it 3 steps as an example. You can also fool around with the flow with the shift here. So obviously it's going to be a little bit slower, and you see you will get better results. See, this looks like this looks more like chickens, but it's still not doing what I want. So sometimes you can fool around with this value, let's say 4.5, and let's see what that one does. See, it takes a little longer. You see what happens? They turn into like the Asian. Oh, what happened there? Oh, I guess that's the image below it. I should have deleted it. Yeah, so that's the problem here. So leave this at 3. You can also change this say to 1.2. Clearly it was trained on Asian people, so that's why Chinese most likely. Yeah, so and you can see you get better quality depending on what you do here. Now if I really want ice, I'll have to I mean there are other ways to do it, but the point was I just want to show you how to get better results. That's the point here, just to get better result. It's obviously ignoring my prompt because this value is too low. I wonder what happens if I go 0.51. I think we all know what's going to happen here, right? 0.51. It's probably going to take more of the prompt here. Oh, I'm more curious. They turn into like, what do you call them? Slavic, most likely Russian. So let's go back to 1 here. Say 1.1. You can have a lot of fun with this. Okay. Okay, so that's why you have to leave this at 1 if you're using this distilled model. So that is actually pretty funny there. Okay, so yeah, so these are ducks. What are this is clearly come on, these are ducks. These are ducks. So yeah, you get some is that a snow? No, that's a feather. That's not snow. Yeah, so that's the thing with so I said you can just fool around with this. You can set it to fixed and whatever. So as I said, this tutorial you guys are seeing is simply just getting better results from your initial image, and so that's I said you can, and fast too. So it's ignoring my prompt. I said I have to bump this value up in order for it to, for example, if I go 0.5, if I go 0.55, I hit run here. You see? Now it gives me the snow. Now clearly I don't want snow. I want I want both the snow and I want my image. So let's try 0.52. Let's see what that one will do. 0.1 is still taking my initial image. What is this one going to do? Oh, ooh, something there. Okay, so I obviously, yeah, so there you go. So if, for example, if I type this one SG uniform, yeah, let's see what that one does. Oh, those kind of, I don't know what that is, but yeah. So I said sometimes this could change, but there you go. So I usually just leave it on simple. Where's simple? Simple, simple, simple. Let's try that one. Yeah, so you see it's taking more of my prompt instead of the image. So this one, let's dump this down 0.51. Okay, 0.5. Yeah, so there we go. What is wrong with the bottom of the feet? Okay, so that's what I'm saying, like, yeah. So yeah, so just for with the noise, obviously if the more prompt if you give a bigger prompt, it will actually keep to your prompt. All right, so that was snow environment, photorealistic, cinematic lighting isolated in a pure white background. So this one is a cloudy environment. Everything else is the same. Photorealistic, cinematic lighting isolated in a pure white background. Okay, so this one is for the man wearing a watch. Where's the man wearing MMM for man? Should be here. MMMG man wearing watch. Here we go. So let's run this one. Let's see what came out here. Oh, the man is steering a watch. Okay, to kind of clean it up a little bit. That's actually pretty good. So I need to go lower. No. Is it higher? Oh, I need to go a little bit higher. So 0.51. Because I still want the cloudy stuff. Yeah, so there we go. So it can't decide between, it will give me the cloud or it will give me the man wearing watch. It can't combine them together. But I'm saying there's ways to do it. So obviously I can get rid of this VA. I can put a regular VA in code and just get the decoder. So you can also do that, and I'll show you. I think the decoder goes here. So you can load the regular decoder. Type load VAE. Or you can use the GGF version. I think I use the GGF version. So here we go. And you see the problem with the regular one is this one wants to go to your, I think this one goes straight to the decoder, and then you can have one where it goes here, but I want to use the image, so I can't use this one. Same with the regular one, so that's why I decided to do it that way, like this. Now if we look at the default template, I'll show you the default template here. Just type Z image, I think it is. Yeah, Z image. This is, I think this is the one I used, or this one is one of them. Z image, text to image turbo. So let's look at the regular one. Now I deleted some of these because I don't need them, but you see it uses BF16. So I said make sure you understand what your GPU is capable of. Okay, so this is the default one. I'll show you this one. So you see this one uses ZBF16. I said this will be slow in my system. This one I think is the FP16, so that's fine. You see Lumina 2, and this is AE safe tensors, which I have. And what happens here is this one takes the image, it goes to late. This one has a latent image where you put it in there, and the prompt. So everything is basically the same, as you can see here. So this one, you can see this one uses 9 steps. CFG is 1 as well. It is simple, and ROS multi-step. I should actually try that one, multi-step. So I'm gonna get rid of that one. Let me try the multi-step one and see what that one does. Sampler name. I tried the res multi-step. Oh, by the way, if you install if you use, what I found was that if I don't use a wheel and I instead use the Fedora repository, PyTorch and all that, I'm able to actually use all this. We see where it says _GPU. I'm able to use all of them. The only one I was not able to use was this one, the 3M underscore SD underscore GP, but I was able to use the rest of the other ones. So which one we want was the multi-step. Let's try the multi-step one. Hit run. Yeah, so you usually get different results depending on what type of sampler you do use. So let's go to this one. Yeah, so I said you get, for example, if I keep on running it, I might even get just different results all the time. Yeah, see that? You just get different results. Now you see 0.5. If I go to 0.49, it should use more of my initial image. Yeah, you see, it's not combining them properly. So the problem I said is because of this these two here. They're meant for speed. So if you want speed, you do use them. Otherwise, you have to use the default one as I showed you there. So let's go take a look at the default one as well. Let's go Z image. Oh, just type Z. This fun control net. I deleted this as well. I said I don't have this one. I thought I downloaded this. I must have deleted it as well. So if we go here, this one is Canny and image processor. So you put the image here, it goes through here, and where is the decoder? And oh, that's it. Oh, that's actually pretty simple. Oh, it has a special. Okay, yeah. So we have another prompt here as well. Okay, so this one doesn't even use the VAE. Oh, interesting. Is it here? Oh, this is an upscaler. So what I'm saying is that you see it's already crossed out, and that's a good thing, because I said if you get the proper one. You know the funny thing about this model, it can also do the scaling and everything for you. You can actually output the if I type in I want 68 by 78, it will actually do that as well. So this model is actually pretty good for that. So there we go. All right, let's finish this up. So what's the last one? Oh, this one, by the way, was cloud environment, photorealistic, cinematic lighting, isolated in a pure white background. And this one is going to be dusty environment, photorealistic, cinematic lighting, isolated in a pure white background. So I'm going to paste that in here. This is for the spider web. And SS for spider, RS spider. Here we go. Put it in there. And I'm gonna hit run. Does it show here how long it takes? Okay, it is pretty fast, as you can see. So if we go back to the command line here, as you can see, this one took 5 seconds, but that's the first one. If I run it again, it'll be much faster. You see 2.5, 2.3. Yeah, so if I wasn't running OBS, I'm pretty sure some of these things I'm fooling around with, I'll probably even get it faster, but I'm happy with that result. So, this one came out actually very good, because you see this one actually added dust. You see it added the dust. In case you don't know what I'm talking about, this is the original image. Oops, I opened it up twice. So this is the original image. You see there's no dust on it. This one actually added some dust to it. So as I said, like as long as you fool around with that denoise level, you will be able to get the results that you want. And I was pretty happy with this result. Yeah, very happy with that. Obviously, again, if you make this value say 0.6, you get you get the dust. I don't know why it's pixelated. Is it because I've blown up? I wonder why it's pixelated all of a sudden. Let me try Euler. Oh, I think I was using Euler Ancestral. Let me try that one. Is it still gonna be? Yeah, it's still pixelated for some reason. Let me try. Yeah, I don't know why it seems. It's just me, it looks pixelated. Okay. Yeah, so that's how you can get it. I just want to show you. So you can use this TAESD, the encode, and the the decode in order to get the results you want. So for example, I could cross this out. I don't need the encoder. What I can actually do is if I type here with spider web, okay, just as an example, just to show you what it's going to do here. Oops, why is that white? Oh yeah, so sometimes, yeah, sometimes you have to be careful here. Oop, what is going on here? Sometimes you have to be careful. Yeah, sometimes you have to be careful where you put the prompt as well. I found this out the hard way. So for dusty environment, spider, I'll put spider web in here and see what that does. There we go. You can see something there. I don't think it's using my spider web, but what did I do here? So let's make this 0.8. So as you can see, the more specific you are, it will actually start using your image there. So obviously, if I put this to 1, it's completely not even going to use the image. It's going to be 100%. It's going to be the prompt here. Yeah, see, it's 100% the prompt. So if I put this, let's say 0.25, it most likely will just use the image. Yeah, see, it's going to use the image, and it didn't make any change at all. If you remember, there was some it didn't use the image. So I said it depends on what value you put here. So if we say 0.4 and run this, you see it did make a change here, but I don't see any dust, honestly. Is there dust there? Yeah, I can't tell. Yeah, so that's it. Now I want to show you some of the things I was able to get using this. Where is the folder? Is the one here? Yeah. So I was able to get some results. Do I have a specific folder here from the video? Where is it? Oh yeah, here. Let's see. I was trying to create a character cleaning the chicken hoop, and the problem I was running into was that it kept on changing the outfit, right? So that really frustrated me. So what I did was I came up with a prompt where I had to describe the hoop coop. I had to describe where the person was standing, what they're wearing, and and then you see I was able to actually get some consistency, and yeah, so I was able to get it. And you have to. I even had to describe the shovel because things keep on changing. So it's the same model, and then when I want the person inside, I have to describe you have to be very specific. And as you can see, I was able to. The funny thing is, all I said was cleaning. I said cleaning. I didn't mention poop or anything. It drew that to itself. So you have to be careful as well, because obviously it's a keyword. It's not fully precision, but yeah, it can do some things or make some assumptions which turn out to be accurate. But yeah. So one of the problems is what I'm doing is if we go back to the first image, you see there's this pails, I guess, in the back here. So you have to describe this as well. Otherwise, it might remove them. It might even change this into wood. You have to be very specific. So that's why I had to be specific. So that it kept on showing them there, and again and again and again. So it's a very short story, but it was such a pain to get it to do what I wanted. And obviously, this is Olivia Chow, allegedly. Right? So, and then I used that to, so the idea was to generate some videos, and I'll show you, this is using the one FunB model. Yeah, so we see that one. this one doesn't have. I did it a few times just to test it, obviously with speed. You see, this person has what, 3 hands? Yeah, so just a fun thing here. Yeah, so that was the last one. I think this is the last one I did. Yeah, so I was just testing to make sure it works. What is the person doing there? What was that? Yeah, so yeah, the hallucinations are kind of weird. I was just trying to get some transition. Some pretty funny transitions. And so what I did was, I think I have a template here. Yeah, here we go, the fun, this one here. I'll show you what the workflow for that one is. So you see I'm using the I found an FP16. Remember, by default it's BF, so I found this one, FP16. I also found FP16 for the text encoder, and for the VAE I found this one. So I think it's the default one. And then the clip vision, I think I found this one. Yeah, and then it's the this one takes 2 images. So it's this image and then this image. So it's supposed to transition from this one to this one. And then I was hoping to do this with stable diffusion, but it was a little bit slower. And then you see this one, you have the this doesn't, this was the default one, but I put my prompt in here. I'll show you an example prompt I used. Don't worry, I'll show you the example prompt. And you see, this is the default stuff here. I don't think I changed any of these. Yeah, I didn't change any of these. I didn't change that. This one, they see the shift is 5.0. The case sampler stuff here, I put it at 5 steps. CFG I set it to 5. I used LCM. LCM is actually pretty fast. I should actually try that one as well for the LCM. Simple, and the denoise is set to 1. You see this one is a V8 decode. I can probably change this part. Will be much faster using that one as well. So we can run this, but before we do that, I want to show you what else I want to show you here. You know, let's run this. This one I know I'm gonna need, definitely I'm gonna need, what is the temperature? 50, that doesn't make any sense. I'm not running anything. Temperature shouldn't be that high. Okay, so I'm gonna set the temperature to say 40. And I'm gonna run this. Go to the command line and see how long it takes. The first time it's gonna take a while, of course, but you'll see. So while that's running, I'm going to check the live chats. Odyssey, Rumble, BitChute, and YouTube. Okay. So today was supposed to be a celebration. So let's. This is just a quick overview. So I believe I have 1,000, just over 1,100 YouTube subscribers. And then I have on BitChute, I have, it says right here, 38 subscribers. On Rumble, I have 139 followers, and on Odyssey, I have 42 followers. So I'd like to thank all of you. Those are the main channels, by the way. There's also some sub channels for the Tech Rants. Tech Rants, I'm very close to 100 subscribers. Thanks for that. And there's also Spotify. I can't remember what the number is there as well. Spotify as well. Thanks everybody for following, and keep it up. I said I was gonna celebrate here. I think I was gonna do something special, but I said I was so tired, and I had my brother-in-law's brother gave me some chocolate. I was going to actually consume it yesterday in front of you guys, but as a small celebration. But I ate all of that yesterday. Actually, I'm not a fan of chocolate anymore, So when I get it, I try to consume it as quickly as possible, get it out of the way. Because I'm also on well water, so I don't have chlorine. I mean, so it's you know, I don't want to get plaque or anything, so I want to get rid of it as quickly as possible. I can't give it to the chickens because I know it's not good for them. So yeah. So you see the problem here. If you remember, you see here it says 15.65 or 17 basically seconds per irritation. So this is why it takes so long. And I'll tell you why. You see, we can tell why it takes so long. So you see this one, I loaded the TA. So if I use the TAESD, it will be much faster. But the reason why this is taking so long is we can check up here. It's using a split attention in VAE. So you see, it loaded the model pretty quickly. The one model, all this stuff loaded. So one of the problems here is it's still offloading to the CPU. That's obviously slow. I don't know why it does that. It should simply, there's enough VRAM. I don't know why it doesn't just stay in the VRAM. It's a small model. It's a 1.3B. It should not use the CPU at all. It should just be doing everything in the VRAM, but for some reason, I don't know, maybe it's hard-coded somewhere. And you see it's finished. We'll take a look at it in a second. And you see it took 217 seconds. That is, I believe, 3 minutes. Very close to 4 minutes. So that's obviously it's usually so that's a 4 minutes. Yeah, about 4 minutes. Just under 4 minutes because 180 is 3. Yeah. So this I mean, it's okay. But I wish this would be fast. I wish this just loaded everything into VRAM instead of using RAM. So maybe I'll have to find a way. But I think this my new favorite TAESD. That's a tiny encoder. I'll probably replace this, and this will be much faster. Obviously, if I run this again, it's going to be much faster as well, right? So let's take a quick look at this video that was just generated and see what it looks like. Okay, so I need to make it a little bit smaller so people. Okay, so let's go. Let me. So let's play this video, and you see what's happening here. Right? It's a little bit jumpy. I kind of like the jumpiness there. Because I said, so basically the idea was I want to tell a story, so I want to generate some images, and then what I was going to do is I was going to put them in Blender and then do a transition. I obviously talk over it, but then I decided, you know what, since we have the AI, why don't I animate? Now some of you might be saying, why don't you just tell it to do something that, and just create the video from let it create the video. The problem with that is that you see this one, this is the first image and the second image, the first frame and the second frame, right? So if I don't like the first frame, or if I don't like the second frame, I can regenerate them. The problem is if I get it to create a video, let's say the video takes 20 minutes or 30 minutes. The problem is if the first frame is bad, the rest of the video is going to be bad. You see my point? Then I have to wait another half an hour or longer to generate another video. So that's why I don't want to generate everything using I don't want to tell my story using the video. Now if there was a way, I don't think that's possible right now. If I could generate one image, like say this one, the first frame, and tell you to do something, by the way, I've tried that as well. I'm saying later on it actually it kind of starts hallucinating. So my point is that I don't want to stick around half an hour and then run another half an hour. I'd rather have a few images here and then transition from the first one to the second one, etc. Even this one, it's meant to be funny. So something like that, I'm perfectly okay with that, right? Now, as I said, these images were generated, I think, using the Q3 version of the Z Image Turbo. So clearly, this is just a work. I don't want to say work in progress. This is just a test. to see what it's capable of doing. I said I'd rather have done this with stable-diffusion because I can just command line and a few things and you just run. But ComfyUI is much faster, especially when you can do these tweaks like I just showed you. So I am very happy with this. Obviously, for example, this was a Q3 mod. I said the problem is, you can see, for example, the door is the door is wrong, of course. So what I'm saying is that those are the type of things with precision. So I'll probably regenerate all these images using the Q8 model, and then I will run it through the WAN 2.1. I'm pretty happy with the way WAN 2.1 does. It basically transitions from frame to frame, so I can do that as well. I actually do like the way it's bouncy here, because yeah, you see even that part where the person clicks here and then it goes up. I kind of like that. So yeah, I was hoping to generate this before Christmas and have this as the Christmas day, but I'm glad that I did the BSD licenses instead. Okay, so that's basically all I wanted to show you guys. I was just showing you that as long as you know what the limitations of your GPU, you can work around them. And I said, like, especially if you have a non-NVIDIA one, you can install the so I'll show you how I installed the custom nodes. So all I did was I went to ComfyUI, I went into the custom nodes. Where's custom nodes here? Custom nodes. And all I did in here in this folder, I just did a git clone of gguf ComfyUI use TAESD, and I did this ComfyUI gguf. I was surprised that I thought this one came with everything, but it was missing some stuff which come in gguf, and then it was also missing this use TAESD. Now, speaking of TAESD, the tiny encoder, I'll show you. I believe I have links for that one. So let's go and take a look at those links. Where are the links? ComfyUI. I also have a ComfyUI one here. I'll show that to you. We'll leave this for now. I think we don't need this anymore. And we go here. Actually, no, maybe I should. You know what? I should actually do that here. Where is the ComfyUI? Here's ComfyUI. So we should actually do it here. So this is ComfyUI. That's what I'm using. You can download it. There's also a portable version, and just follow the instructions. Pretty easy. And you guys saw me. I did an update. So there we go. That's ComfyUI. Now the one I want to show you guys is the tiny encoder. See this one? It's made by Olin. It's called the Tiny Auto Encoder for Stable Diffusion. So you see it's called Tiny Encoder for Stable Diffusion. What is TAESD? That's the name. Tiny Auto Encoder for Stable Diffusion. It's a very tiny auto encoder which uses the same latent API as Stable Diffusion VAE. The TAESD can decode Stable Diffusion guidance into full images at nearly zero cost. Here's a comparison on my laptop, so you can see there. And as you guys saw, when I set it to 1.0 for the denoise, it did a really fast job. So that's what they're used for. Of course, there's a few artifacts. Now, the reason I came here is because you see here it says for Flux1 use TAEF1 underscore whatever weights, and it says for HDream and Z image, which use the same VAE as Flux1, you can also use those weights. So that's why you saw I use the encoder and decoder for that. Now if you have Flux2, you have to use the TFE2, and if you have Quen image, there's also use the same one as 1.2.1 does. Actually, 1.2.1 actually does use it, so use this one, TAEW 2.1. I'll click on that and show you how to download it, and I use the parallel downloader, and then there's others here as well, and they were saying how so that's why I custom installed it here. And you can see some of the they explain what some of the limitations were. If you want to decode detailed high quality images, don't care how long it takes, you should use the original SD VAE decoder or possible OpenAI's consistency decoder. TSE is very tiny and trying to work very quickly, so it tends to fudge fine details. For example, here you can go read that yourself. However, I'm pretty happy with it. I said mine is for my particular story. I would definitely use it. So you know what time is it now? Okay, so I think we have time to try this out because it's already been downloaded for the what's it, the Quen 2.1. So let's actually go here. I think it's on Hugging Face. Example order 2.1 notebook. Oh, where to get it? So where to get it in ComfyUI? Thanks to PR, you can get it by the video wrapper, KG, ComfyUI Blast, Stable Diffusion, SD Next. Okay, so it explains how to get it, but I got it from ComfyUI. Okay, so basically, sorry, not ComfyUI. I got it from Hugging Face. So you just go to Hugging Face, and then you just search for, I already forgot the name. This one here. Is that the one for the video? Oh, this is the one for the video. So just grab. Oh, come on. Oh yeah. It's one of the problems when somebody puts a period at the end there, it doesn't come out. So just put there. And I got it actually, I think from this person's, how did I find it? Okay, I'll have to look at my notes here. Where in the world did I grab it from? That's the Z. No, that's not it. That's when I got it from, here we go. I got it from Runware. Yeah, this is where I got it from. I got it from Runware, and you go to Files, and this is one I got. So this is one I downloaded, the TAEW 2.1 PIF. This one here, you see it's 22.7 megabytes. That's why I downloaded, and you can read all about it. License, it's MIT. I also did an MIT license as well. I think that was my first license one. So you can. I don't know if this will work in ComfyUI. Look, you know what? Let's go try it out. So this one is for the decoder. So if you don't know what that means, it means, you see, after from the case sampler here, you see it goes to VA decode. So what you can do is you replace this one with it. So I'll show you. So let's go here. We go to the nodes here, nodes, and you just type TAESD. We want the decoder. You can get the tiled one if you have less, even more less RAM. So grab this. Oops. Oh, come on. Oh, yeah. So this is the one here. You see, it's found the model here. That's another one. So what we want is. This one doesn't actually support it, so I have to get another one. Okay, so this one doesn't support it, so I can't use it here. It only has this. This one is for the Z image, and this is SD3, SDXL, and the default stable diffusion. So I can't use it. I probably need to find a special mod for it. So what I would do is, if the one that supports the PIF ones, you would put it here. Oh, I think I have to rename it. I think that's the thing. I have to rename it. Yeah, it needs a special name. It has to have .safe sensors to find it. So let me actually try that. Let's go and try that. Let's go it's in models. Where's models? We go to VAE approximate. So this is the name. I'm just going to rename it to safe. I'm going to call it decoder safe sensors. I'm going to copy this. copy that, and I'm gonna rename this to okay, so I'm wondering if it's gonna be picked up here. Let's do a reload and just refresh it just in case. Reload. No, it doesn't. Okay, it doesn't work, so that's not. So we'll just undo here. Yeah, so that's fine. So it doesn't work, but I think this might work with stable -diffusion. I'll test it out and I'll let you guys know. So the names have to be like this, you see, TFE, and those are the names. So those ones do work. This one, fortunately, doesn't work unless I'll have to maybe search for what do you call it? I'll have to search for a node that actually does work, and then I can replace this BAE decode, and that'll be fast as well. So that's basically it. Let's finish up this tutorial and go back here. So I do have some resources. I have books. They're available on Amazon. I have Learning Python. The link is also in the description. It goes to the Amazon page. I have courses. I have Learning Python course available on ojamboshop.com. The link is also in the description. And if you need any some of the service, like for example one-on-one Python tutorials, you can contact me on ojambo.com/contact. And if you need ComfyUI or Z-image or anything AI related, or just consultations in general, ojamboservices.com/contact. So in conclusion, Fedora 42 with ROCm 6.3 remains the safest choice for AMD Instinct MI60, but Fedora 43 with ROCm 6.4 and Python 3.14 offers newer system features but no longer provides official GPU support. Beginners should prioritize stability, while advanced users may explore Fedora 43 with caution. Now, obviously, in today's night stream, I showed you guys how you can, get some speed, some speed improvements, and you can even get faster speed by changing some of those settings as well. Okay, so, and then I also have some other recommended resources. I live in a rural area in a cabin, and there's no internet. The cellular service is sporadic, so I use SpaceX Starlink residential service. It gives me high-speed internet. For example, right now I'm live streaming on YouTube, Rumble, BitChute, and Odyssey. And I also use it on my phone for Wi-Fi calling, so I'm able to receive calls, text messages, including multimedia ones, and send them as well. So it's fantastic. So if you do use my referral link, I'll get 1 month free, and you'll get a massive discount. For example, right now in Canada, you get the equipment for free. If you're somewhere else around the world, the type of discount is duration will be dependent on your geographical location, but you will get a massive discount. I also have an affiliate link for this Honeywell HeatBud personal ceramic heater. I do use it. It saves me hundreds of dollars in propane per month. Right now I'm saving over $200 a month, because what I do is I set it on high. It has two settings, low and high. I don't know if you guys can see that. Low and high setting. Low is 170 watts, high is 250 watts. It also has the protection. If it tips over, it triggers this little guy here, and that will turn it off. So most of the time I have it on low. The only time I have it on high is if I accidentally hit the high button. So it's only about $3 a month extra on electricity. I'd rather pay $3 a month than paying $300 plus for propane. Okay, so you can pick this up on Amazon. This is my affiliate link, meaning that if you do purchase it, I'll get a commission. There's no extra cost to you. I also have the Algorithmic Serpent. If you're interested in reading about psychological thrillers, see, it's by me, Ojambo, and this one is about a scientist who creates an AI system and loses his mind, so he has to regain control of his mind and the AI system. This is the back. This is the paperback version. There's also an ebook version. It's very affordable. It's mostly at cost. The cost for printing and shipping for the paperback version, and storage for the ebook version. If you have Kindle Unlimited, you can pick up the ebook version for free. My latest is the Recession Business Blueprint. It's a guide to help you start a business during the recession. It has a lot of tables, there's a lot of text, and it's not just based on how I started my business during the last recession in 2009. I also updated it so that you can find ways to do your research for the type of business you want to open up, where you should run your business. Because if you're on a budget, obviously running your business at home is such a smart idea. And then like for example, where to get the suppliers, where to get the customers, how to advertise, promote your business as well, or obviously on the cheap, right? So yeah, that's the best time to start business is during the recession, because you will learn skills on how to minimize and how to be frugal, and those are key. Because for example, right now in a recession, I learned how to do this way back in 2009, so now I can be frugal again, and then when the economy obviously improves, I can spend some. I can spend some more or not. It's up to you. So yeah, pick it up. It's available right now on Amazon, and there's an ebook version as well. The ebook one is also free if you have Kindle Unlimited. For both of this too, I have a dedicated video and a short version of when I did review them. Just a quick overview introducing them, so you can watch that. If you have any questions about business or AI, you can contact me. I'll show you the ways you can contact me. You can, if you want to learn more about me, I have a blog in every article I write. You see my book page on Amazon. If you need support, ojamboservices.com for consultation services. And if you're ready to learn, ojamboshop.com for the online courses. There's also PHP and Python and JavaScript. And you see, I'm a software engineer, web developer, and author. So remember, I promised you ways to contact me. So you can write a comment, for example, just under this live stream right now, in the live chat, or under the comment place there. Or you can also write a comment here for this article. This article is not going to be up for too much longer because it's only 10 days or so. So this article I said is already 2 days old. But you can write as long as it's based on what the topic is about. Obviously AI, Z image, ComfyUI, Fedora 42, Fedora 43, that's perfectly fine. Best way to contact me is to use the contact form, ojambo.com/contact, ojamboservices.com/contact, and ojamboshop.com/contact. And if you want to follow me, the channels, I live stream every day: Odyssey, Rumble, BitChute, and YouTube. Okay. That's the end. I want to implore you to subscribe, like, follow, and leave comments. I'd like to thank everybody who subscribed so far this month. Keep it up. As we hit a milestone. Actually, today was this was a celebratory. It's a day late, but thanks again, everybody. And I hope I wish you a happy New Year. And to see you in the beginning. If there's something you want to see specifically, whether it's ComfyUI, AI, or something else, let me know. I'll be more than happy to do a little research, and I can create a video for everybody. Alright, now I'm going to show the outro, and we're going to go back up here, and I think I'll stop just about here. I think that's good. Yeah, that's good. Alright, so if you want to know what's upcoming, you go to ojambo.com, you go to Watch Menu, Live Summary. You can see, for example, tomorrow what we're doing at 2 p.m. Eastern. We're doing this one here, which is the native Android RTSP webcam in Kotlin. So this allows us to create our own webcam using an old phone, or if you want to use your current phone, that's fine as well. And this way you can get better quality. So for example, right now I'm using a webcam. This webcam is really old. Yeah, it's really old. It's actually even older than my old workstation, which is already in pieces there. I think I got it in 2010, if I remember correctly. I think, 2010 I think I got it. So anyways, the point is, it's a very old webcam, and it's obviously not as good quality as phones, even the mid-range phones. So if I could use a phone, it would be perfect for that. So that's what I'll show you how to do that tomorrow. And then the day after that, we have a topic. Oh, there's actually another topic. I think, I'm surprised it didn't show up here yet. I must have done something stupid, but yeah, there should be another topic. Actually, there should be 2 topics here. I don't know what happened, but they'll show up. I'll investigate it. There should be 2 topics here, and there should be 2 more topics. The fun little topics. So yeah, they'll show up. I'll investigate after this one. They should show up. Okay, so that's it. And oh, I forgot. I'm gonna check the live chat. to see if there's any chat requests. Nothing on Odyssey, nothing on Rumble, nothing on BitChute, and nothing on YouTube. Okay, that's fine. Thanks again for joining this night stream, and I'll see you guys tomorrow at 2 p.m. Eastern.